Consider the following data output. So over here, we are running a regression of log of wage on education, experience square, and male. So log of wage is the dependent variable and these four are the independent variables. And they are asking us what is the number B equal to. So B over here is representing adjusted R square. So we have to find the value of adjusted R square. So over here, we can directly use the formula for adjusted R square. We know the formula for the adjusted R square is 1 minus SSR divided by TSS multiplied by n minus 1 divided by n minus total parameters. Okay, I'm deliberately not using any notation for total parameters because sometimes the notations could be confusing. So I'm just writing it like this. Okay, now what is SSR in this question? Well, this is SS, so this is your sum of squares and you can see residual over here. So your SSR, that is your sum of squared residuals, is this. So we can write that your adjusted R square is equal to 1 minus, instead of SSR, I can put 66.24. Now, what is your TSS? TSS is total sum of squares. So you can see over here, your total sum of squares is this. So this is 165.65. Lowercase n represents the sample size and we can see from here that the sample size is 935. So this is going to be 935 minus 1 and then this is divided by 935 minus the total parameters. Well, how many parameters are we estimating in this model? So we are estimating 1, 2, 3, 4, 5. So in total, we are estimating 5 parameters. Note that you don't have to do n minus the number of independent variables. So this is one common mistake that students do, that they count the number of independent variables. So the number of independent variables over here are 4. So they end up doing n minus 4, which is completely wrong. So you don't have to do n minus total number of independent variables. You have to do n minus total number of parameters. And when we talk about the total number of parameters, we have to also count the intercept parameter. Okay, so there is also going to be an intercept term. So you have to count that parameter as well. So now when you solve this, you will get that this is equal to 1 minus 0.3998 multiplied by 934 divided by 930. And this is equal to 1 minus 0.4015. And the final answer is 0.5984. That means the right answer is part